So these are the problems on the front side of the study guide for Test 1, Term 2. So let's go ahead and take a look at the first problem. It says determine whether the point 618 is on the graph of the given line. Well, all you're going to do is you're going to just take your x value, which is 6, and your y value, which is 18, and substitute them into the equation below. So I'm just going to rewrite it. I'm going to put this 6 again. That's going to go right over here in place of x, 18 in place of y. Then I'll rewrite what I've got. So I've got 2/3, and then in place of x, we're putting 6. Now I'm going to write that as a fraction, 6/1. And this all equals 1/3 multiplied by 18. But again, I'm going to write that as a fraction, 18/1, and then minus the 2. Well, from this point, I can go ahead and do some cross-canceling. I can divide 3 into 6, and that goes in 2 times. Multiply across, and I've got myself 4. This all equals, well, on this side I can cross-cancel as well. 3 goes in 18 6 times. Multiply across, and I've got 6. And then bring down that minus 2. Well, from that point, we can go ahead and collect some like terms right here. 6 minus 2 makes 4, and it equals 4. So what that means is when we have the same numbers equaling, that means, yes, that point is on that line, and here's the proof. So on the test, I want you to write down, show that substitution, and then show how the two numbers equal. Don't just leave it at 6 minus 2. Go the full way, say 4 equals 4. And that's proof for me. Well, the next one, it's asking the same thing, but just in different terms, different words here. Determine whether the point -2, -12 is a solution of the equation. It means the same thing. So all you're going to do, same thing, you're going to take your x value, -2, and you're going to put it in for x. Take the y value, -12, put that in for y. See if they equal or not. So we can go ahead and rewrite our equation. We got -6 multiplied by the x value, which is -2, minus 1/4 multiplied by the y value, which is -12. And this should all equal 9 at the end for us to say yes. So I go ahead and do the work and multiply these two numbers. I get a positive 12 because the two negatives cancel out. Over here, 4 goes into 12 3 times. Multiplying across, the two negatives make a positive. So I end up with a plus 3. And so those two numbers don't quite equal. Now, if it were a positive 12 we put in here, then I would subtract and I would get a positive 9. But here I don't. I end up having to add, and I get two numbers that do not equal. And that's when you say no. So again, what I'm looking for on that test is the substitution. Make sure you substitute those numbers into the variables and then do the work. See what you get. So again, I'm looking for that substitution. That would be the answer for that problem. Well, the next problem asks us to find x and y intercepts. So what you need to remember is that when we're trying to find that x-intercept, we need to set y equal to 0. And then for the y-intercept, we're going to end up setting x equal to 0. So we go ahead and do the work there. And when I set something equal to 0, it cancels that term out. So for the x-intercept, I'm left with 1/16 x, and then it just equals 9, because again, that y term canceled out because I set it equal to 0. And so from that point, I need to do an opposite operation to get rid of that 1/16. I'm going to multiply by the reciprocal. So I do that, the 16s end up canceling. So what's left over? Well, I still have an x, and x ends up equaling, that makes 144 when I go ahead and multiply those two numbers together. Well, that's my x-intercept, so let's take a look at the y-intercept now. Now, for the y-intercept, I need to set x equal to 0. So when I do that, all I'm left with is that negative 3y equaling 9. So again, this term all cancels out because we multiplied it by 0. 0 times a number makes 0. And so from there, I go ahead and do some division, and I'm going to divide by negative 3. And again, make sure you watch those signs carefully on the test, because here I just have one negative, so it's going to make a negative. So negative 3 is the y-intercept. And that's all you have to do for me. It'll say x-intercept, and you just write down equals, and then write down the number. If you wanted to write the ordered pair, it would go this way, 144, 0 for the x-intercept, because the x value, it comes first, and y was 0 again. Over here, it would be 0, negative 3, because the 0 is what we set x equal to, and negative 3 is what we got for y. And that would be our answer. So either way, you can write the answer. Well, we've got a graphing problem, 3 graphing problems on the test. So on this first one, you can use any method to graph. Whatever's fastest for you. I find this problem is a good one for the x and y intercepts. Again, the x-intercept, I'm going to cancel out the y term. Y term's over here now. So it's going to be negative 3x equals negative 9. So when I go ahead and do that opposite operation, when I divide by negative 3, this time the negative signs cancel. So x equals, in this case, positive 3. So I'm going to go 3 spaces over on the x-axis. I'm going to put the dot right there. Well, the y-intercept is, again, when I set x equal to 0. So when I set x equal to 0, this term's gone. So all I'm left with is 9y equals negative 9. Well, from that point, I've got one step to do, and that's to get rid of the 9 by dividing by 9 on both sides. And so we're left with y equals negative 1, because there's only one negative in this case. So I just go down one space on that y-axis, put the dot there, and then draw the line between those 2 points. So that's probably the fastest method to solve that problem. You could, again, use slope-intercept form, and that's the method I'll use on the next 2 problems. I'll use that on the second problem because it's really easy just to divide by negative 2 in this case. See, y is almost by itself, but if you do that, you got to divide every term by negative 2. So what's left over? Well, I've got the y, and it equals, in this case, negative over a negative made a positive 3. So I'll put a plus sign there in front of the 3. Here, these two cancel out to make a positive 2x. Now, if I write it this way, I have to be really careful about what is my slope and what is my y-intercept. So in this case, my y-intercept is the point I need to start with, and that's positive 3. So that's the y-intercept. That's where I start. So I'm going to go up 3 spaces and put the dot there, and now I'll use the slope. So the slope of the line is 2. So I can treat that as a fraction as 2 to 1. So remember, the slope is always the number in front of x. It's called the coefficient of x. So what I do is I go up 2 spaces from that point, from that y-intercept, and I put a dot. Up 2 spaces over 1 to the right and put a dot. I could also go the other way. I could go down 2, 1 to the left, and put a dot. And now in that direction, I can go quite a few spaces down. And then from there, I can go ahead and draw my line between those points. You'll notice if you had used the xy intercept method, it wouldn't have made an integer for the x-intercept. The x-intercept would actually be right in between negative 1 and negative 2. It would be negative 1.5. And then you'd have to put the dot right in between those 2 points, and then draw the line between them. Well, the last problem is another great slope-intercept problem because it's already in the form where y is by itself. So start with that y-intercept and plot that point first. So we'll go up 2 spaces, put a dot, and now we'll use the slope. So remember, the slope of the line is, in this case, a negative 1 over 3. So that negative 1 tells me to go down 1 space. The 3 tells me to go right 3 spaces, and then put the dot. So down 1, right 3, put the dot. I could also go the other direction, which would be up, and then to the left, and put a dot there. Up and to the left, and put a dot. And then from there, I can draw the line between those points. So those are the first 6 problems you'll see. Part 2 will have the last 3 problems on the test.